Question 4D says the height of tree in meters can also be modeled by a function g of x equals 100x over 1 plus x. So instead of using a table of values, now we're going to use this function. And it says where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base is increasing at a rate of 0.03 meters per year. So that rate is a derivative. It's the change in the diameter x over the change in years. So I've written it over here in green. dy by dx is equal to 0.03 meters per year. Now the reason why I do this is because we're being asked here to find the change in the height of the tree with respect to time in meters per year. And we're finding that when it's 50 meters tall. So this problem is a related rate problem. Okay, so we are trying to find the change in height, or the dh, or in this case we're using g as height, dg by dy. Okay, we are given dx by dy, we need to find dg by dy, we have a function g of x. This is a related rate problem. Okay, so to do a related rate problem, we need to be able to differentiate this function implicitly. And by differentiating this implicitly, we're going to differentiate dg by dx and then add on as a chain rule dx by dy. Okay, and that dx by dy is a known quantity. When we apply this, we also need to know we're probably going to have embedded x values, so we need to know what x is, and we need to know, in this case, we have to figure out x based on I'm going to do this in color here. We need to find the x value, or the diameter, when the tree is 50 meters tall. Okay, so to find the x value when it's 50 meters tall, we know that g of x is equal to 50 when for some value x, and that value of x is what we need to solve for. Okay, so solving this algebraically, we end up with 50 plus 50x is equal to 100x. 50 is equal to 50x, and that gives us an x value equal to 1. So when x is 1, the height is 50. Okay, so that needs to be known. Once we do that, we need to generate our dg by dy, and to do that, we differentiate this implicitly. So I differentiate dg by dy is equal to, we're going to differentiate this into dg by dx. We're going to times that by the dx by dy. Okay, so the rate that we're going to need the derivative here, so working out the derivative of this, it's going to be using the quotient rule, 100 times 1 plus x minus 100x times the derivative of 1 plus x, which is just 1, and that's all over the denominator squared. Okay, so then simplifying this expression, we're going to end up with 100 plus 100x minus 100x, which just gives us 100 over 1 plus x squared. Okay, so that represents the dg by dx. I need to make sure I include on here times dx by dy. Okay, we know that value is 0.3 meters per year. We're trying to find the change in height over the change in y, and we can just calculate that value. And we're trying to find this at dg of dy at an x value of 1 when the height is 50 or the radius or the diameter is 1. So then we can plug in the value of 1 in here. Okay, and maybe I'll do that in the next step. This is my dg by dy. Okay, we're going to then, in this expression, we're going to replace that dx by dy by 0.03 meters per year. Okay, and then we can work out the final value, which is what we're looking for, of 100 over 1 plus 1 squared times the dx by dy. And when we work this all out, the rate of change of height per year at a diameter of 1, or when, in other words, when the tree is 50 meters tall, we're going to get a value of 100 times 0.03 divided by 2 squared, which is 3 over 4, and that represents meters per year, or the units. Okay, so when we look at the mark scheme of this, we need to be able to find, 2 marks is going to be for differentiating dg by dt, or in this, I've written this as y, and applying the chain rule, and then plugging in the value, finding the value of x equals 1 from the height of 50, and then plugging that into the derivative expression to get the 3 over 4 meters per year.